What if one of Plug Power's hydrogen projects became valuable not because of the hydrogen it could produce, but because it already possessed something even more valuable in today's economy? Access to power? That question is at the heart of this story as we explore how a company that spent years developing infrastructure for the hydrogen economy suddenly found its industrial sites attracting AI developers instead, revealing that the real prize wasn't simply the land or the hydrogen equipment, but the electrical infrastructure, utility access, and years of engineering already invested beneath the surface, where the hidden systems that support both hydrogen production and artificial intelligence quietly intersect. When Plug Power announced agreements involving its New York Gateway project and its Graham, Texas project with Stream data centers, many people assumed hydrogen had lost to artificial intelligence. But the reality is far more interesting because the buyer wasn't simply purchasing property. It was acquiring years of infrastructure planning, industrial zoning, utility coordination, and electrical development that would otherwise take enormous amounts of time and money to recreate, demonstrating that the true value of these projects extends far beyond hydrogen production and instead lies in the readiness of the sites themselves to support the next generation of large-scale industrial development. Although hydrogen plants and AI data centers appear to serve completely different industries, they share remarkably similar infrastructure requirements because both consume enormous amounts of electricity, require high-voltage transmission lines, depend on substations capable of delivering reliable power, need access to water and utilities, and require large industrial sites with room for future expansion, which means that a location carefully selected for hydrogen production can also become an ideal destination for artificial intelligence infrastructure, making the competition less about technology and more about securing the hidden systems that allow either industry to operate successfully. Most people naturally focus on the visible parts of these facilities, whether they are hydrogen storage tanks, electrolyzers and pipelines, or massive data center buildings filled with servers. Yet the true value often lies in the infrastructure hidden beneath the surface where transmission lines deliver electricity, substations safely distribute power, water systems support industrial processes, utilities connect essential services and permits, allow construction to move forward, because these invisible systems frequently require years of engineering, planning, and regulatory approvals before the first building can even be constructed, making them some of the most valuable assets in any industrial project. This brings us to one of the most important concepts shaping the future of industrial development: powered land, which is far more than an empty parcel of property, because it combines access to electricity, transmission capacity, substations, utilities, industrial zoning, and a realistic pathway towards supporting hundreds of megawatts of demand, creating locations that are now being sought after by hydrogen developers, AI companies, battery manufacturers, semiconductor plants, and advanced manufacturing facilities alike, proving that in today's economy the greatest competitive advantage may no longer be owning the largest factory or the newest technology, but securing the land where massive amounts of reliable power can actually be delivered. Every hydrogen plant and every AI data center begins with the same fundamental requirement: reliable access to the electrical grid, because electrolyzers consume tremendous amounts of electricity to produce hydrogen while thousands of AI servers require continuous power every second of every day, meaning utilities must carefully study whether the existing electrical network can safely support these enormous new loads without affecting reliability. A process that often takes years and has increasingly become one of the biggest challenges facing large industrial developments around the world. Generating electricity is only part of the challenge because that power must also reach the facility through high-voltage transmission networks designed to move enormous quantities of electricity across long distances, making transmission access one of the most valuable pieces of infrastructure in modern industrial development. Since developers must secure interconnection rights, complete engineering studies, and confirm that sufficient electrical capacity is available before construction can begin, turning existing transmission planning into an asset that is often just as valuable as the land itself. Once electricity arrives at the property, it must flow through a substation where voltage is transformed, equipment is protected, and power is distributed safely throughout the facility, making substations an essential component for both hydrogen production and AI computing because neither industry can function without them. While designing and constructing this infrastructure requires specialized electrical equipment, utility coordination, and significant engineering effort that can take years to complete, further increasing the value of sites where this work has already begun. Electricity may receive most of the attention, but water is another critical resource shared by both industries. Because hydrogen production relies on purified water for electrolysis, While many AI data centers require substantial cooling systems to remove heat generated by thousands of high-performance processors, making dependable water infrastructure, treatment facilities, and discharge planning important considerations during site selection, and adding yet another reason why hydrogen projects and AI campuses often compete for the same industrial locations. Even with electricity, water, and transmission infrastructure in place, large industrial facilities still require the proper zoning to allow substations, cooling systems, storage equipment, utility corridors, and future expansion, which is why industrially approved land has become increasingly valuable as demand for AI infrastructure accelerates. Because obtaining new zoning approvals can introduce years of additional planning and regulatory review, whereas sites that already combine power, utilities, and industrial designation effectively become powered land, ready to support the next generation of energy, manufacturing, and artificial intelligence infrastructure. Long before construction equipment arrives on site, every major hydrogen plant and AI data center must complete a complex permitting process that includes environmental reviews, utility studies, construction approvals, and engineering assessments, all of which ensure the project can operate safely while protecting surrounding communities and existing infrastructure. Because these approvals often require years of technical work and coordination between developers, utilities, and government agencies, acquiring an industrial site frequently means acquiring thousands of hours of engineering and regulatory effort that have already been completed, making permits and approvals some of the most valuable yet least visible assets within any large infrastructure project. A successful industrial campus depends on much more than electricity, because modern facilities also require dependable water systems, sewer infrastructure, road access, drainage, communications networks, and high-speed fiber connectivity that allows enormous amounts of digital information to move continuously between servers, customers, and cloud platforms. When all of these supporting utilities already exist, developers can focus on constructing the facility itself instead of spending years expanding basic infrastructure, dramatically reducing both development risk and construction timelines while increasing the long-term value of the property. Plug Power originally selected these locations because they already possessed many of the characteristics required for large-scale hydrogen production, including reliable electrical infrastructure, access to water, transportation networks, industrial zoning, utility connections, and room for future expansion. Yet those same characteristics now make the properties equally attractive for AI development, because the difficult work of identifying and preparing a strategic industrial site has already been completed, proving that while the technology inside the buildings may change over time, the underlying infrastructure continues creating value regardless of which industry ultimately occupies the location. When hydrogen plants and AI data centers are compared side by side, it becomes clear that they share remarkably similar infrastructure requirements, despite producing completely different products. Because both industries depend on high-voltage electricity, substations, transmission access, water, utilities, industrial zoning, permitting, and large parcels of developable land, demonstrating that the true competition is not simply between hydrogen and artificial intelligence, but between multiple industries searching for the same limited supply of powered industrial locations capable of supporting enormous electrical demand. Viewed from this perspective, Plug Power's agreements involving the New York Gateway Project and the Graham, Texas project represent much more than individual business transactions, because they highlight the growing value of powered land in an economy increasingly driven by artificial intelligence, where electrical infrastructure, grid interconnections, utility access, and industrial readiness may become more valuable than the specific technology originally planned for the site, illustrating how the race for electricity is rapidly becoming one of the defining infrastructure challenges of the next generation. Even though these projects are now attracting AI development, hydrogen continues to offer significant opportunities within the data center industry, because modern AI facilities require uninterrupted electricity every second of every day, making long-duration backup power increasingly important as computing demand grows. Hydrogen fuel cells provide another layer of resilience by generating electricity from stored hydrogen whenever needed, complementing batteries and traditional backup systems while offering a potential pathway toward cleaner, longer-duration emergency power for critical digital infrastructure. Rather than viewing hydrogen and artificial intelligence as competing technologies, the future may combine them into a single integrated energy campus, where renewable electricity powers electrolyzers during periods of abundant generation, hydrogen is stored for later use, Batteries provide instant response to short disturbances, and fuel cells generate additional electricity whenever reliability becomes critical, creating an intelligent ecosystem in which every energy resource works together to support continuous industrial operations and large-scale AI computing. Within this future energy campus, electricity would flow through multiple interconnected systems as the grid supplies normal operations, renewable generation supplements available power, batteries immediately respond to short interruptions, and hydrogen fuel cells provide extended backup whenever additional resilience is required, while advanced energy management software continuously monitors electrical demand, renewable generation, battery charge, and hydrogen storage to ensure every component operates together efficiently, delivering reliable power to thousands of servers without interruption. Hydrogen fuel cells continue attracting attention because they produce electricity without combustion at the point of use, can operate for extended periods whenever hydrogen is available, and can be expanded alongside growing energy demand. Although widespread adoption will ultimately depend on improvements in hydrogen production, transportation, storage, economics, and overall system reliability. As the technology competes with batteries, natural gas, and conventional diesel generators, making hydrogen one important part of a broader portfolio of future energy solutions rather than a universal replacement for every existing technology. After following the entire system from Plug Power's projects to AI data centers, the real story becomes clear because this documentary was never simply about hydrogen or artificial intelligence. It was about infrastructure, powered land, and the hidden systems that determine where the next generation of industry can be built, revealing that hydrogen plants, AI data centers, semiconductor factories, battery manufacturers, and advanced industrial facilities are all competing for the same scarce resources of electricity, substations, transmission access, utilities, and industrial land. Meaning that in the decades ahead, the companies that secure reliable power first may ultimately shape the future of the global economy.